Hello and welcome to our Brainfood Talk. It's been a while. Maybe let's kick it off with a short introduction on our side. I am David Walser, software engineer here at Square.
Yes, so my name is Paul Bohotzka. I'm also software engineer at Square, and we have the opportunity today to talk about railway-oriented programming in C# with you. Okay, so let's kick it off. What can you expect today? We will talk a little bit about programming paradigms, about functional features that we have already in C#, then as a core topic, railway-oriented programming as a pattern, and about our real-world experiences. But first, let's kick it off.
Yeah, let's start with talking a little bit about programming paradigms. So they can be divided into two main categories, the imperative and the declarative. Object-oriented programming and procedural programming are considered imperative. Functional and logic programming are considered declarative. I brought here a short and simple example to point out what the difference between those are. So on the imperative side, we see it's really more about the how something is done. We have here a short example about a list of numbers and we want to have the sum of all numbers that are even. So in the imperative side, we have the for each number in numbers. If the number modulo 2 equals 0, then add this number to our sum. While on the declarative side, it's more about the what. So numbers dot where n modulo 2 equals 0 and sum that up. And this is also a little bit more similar to our human natural language. But enough about programming paradigms, let's talk about functions. Let's imagine we have here our chef, and he's well known to cook amazing meals, but he's also well known for having mood swings. So giving this chef some ingredients as input for his cook method, he will create some great salad in that example right now because his mood is good. But if his mood changes, he will create something else. So we did not change the input, we gave him the same ingredients, but his mood was this time a little bit different, and he created this, in this case, just a plain rice. And what we observe here is something we can consider a state. This chef has a state inside himself, inside his object, and this state is directly affecting the output of his cooking method. On the other hand, there's another chef known, and she is known not to have any mood swings. So if we give her the same ingredients, she will always end up creating this amazing salad. No matter, she does not have any mood, so the output will always stay the same, given the same input parameters. And that's something we could call a pure method. And one example how such a pure method could look like, a very simple one, it's called add, takes two integers and returns the sum, added them together. For example, if we give that function 5 and 2, it will end up in a 7. And what are the characteristics of such a pure function? It's stateless, as I've already mentioned. It has no side effects, and it's deterministic. So I can call this function any time of the day. I can call it even in parallel. Given the same input parameters, it will always end up with the same result. To come a little bit to compare functional versus object-oriented programming, as already said, it's functional is declarative, object-oriented is imperative. Object-oriented handles with objects and methods, with mutable data, having loops and inheritance. On the functional side, we deal with functions and we want to have them as pure as possible. We deal with immutable data, recursion, pattern matching, higher ordered functions, and currying. And just to now look at all those parameters, what is currently available in C# out of the box, we see everything except currying is right now available.
Okay, so now let's ask the question, if we want to go functional, why do we go with C#? Because if we look at what C# is on the Microsoft documentation, we see it's an object-oriented language. So why would we ever use C# and not F#? Because as we know, on the .NET platform, there is a very dedicated and very well-received language called F# that is just there to really support functional paradigm in programming. But I think the thing is more nuanced, because if we take a look interestingly at the Wikipedia article of C#, we see way more paradigms, and it is said that C# is supporting multiple paradigms, and one of it is functional. And I think that is very, very true. And so functional is one thing that you can do with C#, but of course it's just an option to have. So if we take a look at the latest versions of C#, then we see over the last years there have been a lot of additions that support us in the possibility to really use functional paradigms also with C#. And one of the things that we have, and we have that since ages basically, is to use functions as first-class citizens. So what does that mean? That means that we can really pass around a function as we would have done with an integer or a string, for example. So here in this example, we call a method that is called getOperation. We pass in something, we get an operation back, and this operation then can be used to apply it on two parameters, integers, for example. But what operation it actually is, that gets decided in the first line. So the function here is a first-class citizen. What we can do with it, so how could we implement it? We could maybe use such a switch expression here, where we say, okay, we get back a func where we put in two doubles and get out a third double. And then depending on the character operator that we pass in, we decide what function that would actually be. Another example, maybe more from the real world, could be a situation where we have a system that is able to process some input data, some byte array data, for example, and it has two implementations of this process. One is the legacy process that might be super cumbersome to set up, and a lot of weirdness has to be done to get it up and running. And then there is another fancy process. And depending on the config, for example, we could decide what process should be actually taken. And one possibility to implement it is sketched here. So you could really have a function that returns another function, and this function then gets either backed by the legacy processor implementation or by the fancy processor implementation. So everything that is nasty is hid behind this getProcess method, and the calling and the usage of the thing is then still pretty nice, and you don't have to care about those nasty details. One way how we could do this in object-oriented programming is, of course, to use an interface, for example. So if we have an example where there is a messenger and we want to pass in some string data that can be then sent over whatever method, and we are not sure about the real implementation that we will want to have at runtime, then the usual way is to provide an interface that defines the method as it has to be, and then have basically unlimited amount of possibilities to implement such a messenger. And in that case, we could say, okay, there is one where we talk via service bus, and another one where we take Redis pubs up because we can, and we have some Redis lying around. So, and what we usually do in classical object-oriented systems would be then probably on setup of the DI container, we just decide based on some configuration, do we want to use the one or the other implementation of it. If we go more on the functional side, the option would be kind of the same behavior, but we would basically say, okay, we have a send method, and depending on what configuration we have, we delegate it to another implementation. So either to a method that, or to a function that says, okay, let's publish it to Redis, or let's send it via service bus. And that is kind of another possibility how to do it. And the thing that we are doing here is a simple form of pattern matching. And that's the reason why pattern matching has become an increasingly more important feature in C# in the last versions. Let's take a look about some of the options that we have here. So pattern matching could be as simple as this, for example, to say, okay, I have an object, and if this object is an integer, then I want to have this integer already available as a symbol called number, for example. And if I can use this number, then it is already ready-made and no questions asked. It is an integer, because the pattern matching expression made sure that this is really an integer. We can make it a little bit more complicated, for example, to decide if a character is an integer. We can even write something that would have been considered an error back in the days, to say, okay, character is greater than and smaller than 9. Yeah. So, but now this is possible because the pattern matching syntax is pretty powerful, and it can be even more complicated. So, for example, here we have a list of workers, and we ask, okay, is this an employee? And if it's an employee, is a worker. And so if the first worker is an electrician, then I want this electrician to change my lamp. So it's pretty easy to write pretty complicated expressions in a very simple way. And even more complicated situation could be like this. So, for example, here we have a person, and then we switch on different aspects of the person. So if it's a worker and we know its profession, then we can write that one string. If we see it's an employee and it's actually an active employee, then we want to get its department out, and we want to use the department in a return value. Or if we see it is not an active employee, so he's already retired, but we want to have the boss she was working for example. Or we know nothing about it, but just, okay, this person has a hobby and we want to talk about the hobby. So everything here is pretty nice and to the point without any fluff around, and that's the nice thing about pattern matching and why it is so important and powerful if we go to the functional route. Yeah, but of course you could say, yeah, it's maybe just another syntax, but we could have done all these things back then in the days with any language of the times. Sure, we totally can, but I think the benefit is here that it's way more expressive. So we do not have to care so much about the mechanics of the language and stuff, but we really talk about the thing as we want to express it and as we as humans would talk about it. Okay, David.
Yeah, let me take you on a journey. And of course, since we're environmental friendly, let's just imagine going to the train station, because of course we will take a train. So we will start off very simple, very easy, with something that's probably familiar to most of you, with a classic get customer, takes a name, calls the customer service, that returns a customer, and we return that customer. But what if there is no customer? Well, we could make the customer nullable, check if the customer is null, do some logging and return no content since we did not find that customer. And if there's a customer, then we return again the customer, same as before. And to make this more expressive, we could introduce a maybe customer. So this customer service returns a maybe customer. And while calling it, I already know as a consumer, okay, I might get a customer, but I might not get one. So it's a little bit improved, a little bit more expressive. The rest stays the same. Null check is now has no value, but other than that, it stays the same. So good so far, but what if an error occurs? What if the database is down? Well, simple solution here would be to add a try catch. Inside the try, it's still the same as before with the maybe, but now we catch the exception if something goes wrong and log an error, returning 500 with the what went wrong, the exception message. But that's already a lot for just getting a customer. So maybe let's take a step back. Maybe let's try to think about it again. Maybe let's try again with some even more simplified example here. We have a divide function. Take some two numbers, two integers. We give the input and does some dividing, some processing, and we get an output value from that. So good so far in a normal operation, but what if we end up in a problematic operation? As we all know, we cannot divide by 0, and this will lead up in some kind of exception right now. And short warning on this side, explicit code is about to show up. And as I started before, we are on our journey. So let's imagine now we're sitting on the train, we're right on track, which leads to me to introduce railway-oriented programming, what we want to talk about today. So the whole mental idea behind railway-oriented programming is that the application flow is on track, and we're always on the success track or the failure track. And to give a quick shout out to Scott Vlashin here, he is well known in the .NET community for promoting this idea behind railway-oriented programming. He has a lot of talks online, a lot of resources in general, so I can highly recommend them to check them out if you're more interested in that topic. But let's step back to the idea behind it. We have some input, we call something the processing, and we end up on the success or the failure track. So back to our example with the divide operation. Here, everything went well, and we will end up on the success track for the normal operation. But for the problematic operation, we will now end up on the failure track. Well, how could we achieve this? We could introduce a result object that handles this for us and represents those tracks. And it's really not magic. It's really, I would argue, simple. We have a value, we have a string error, and the bool is success that checks if the error is null, and the is failure is not success. And it's really not big magic, I would argue. We could even improve this further to introduce a custom error object. Before we just had a string error message, and now we could introduce some custom error with even more details about the error that's happening. And how would that look like? If we go back to our example with the divide, we would now get a result, and we can check if the result is success. Yeah, then we want to log out or print the value of the operation. Otherwise, we want to say, hey, something went wrong. We could not divide and provide the error message. Here we have to be very careful, because if we are on the success track, we of course have a value, but we don't have any error because we're on the success track. So we should really not mess it up here, because on the success track we cannot really access the error property. Otherwise, it will end up in an exception again. To make this a little bit safer, we could introduce callbacks. So on success, same as before, log it or print it, and on failure, same as before. And to even further improve those callbacks, we could make them fluent and chain them already to our operation. In that case, just divide on success to this, on failure to this. The details stay the same. And to even further improve this, because this is something that will happen now a lot, that we want to do this in the success case and this on the error case, we could introduce an extension method match that takes care of that.
Okay, so as you now see, it's pretty easy to come up with a result object, but the convenience comes out of the methods that you put on top of it. So a lot of extension methods, as David has already showed us. And so I think it's really important to choose an API that is really proper supporting you in all the endeavors that we have here. So we have to take a look at one library that is really well received in the .NET community and that we are using a lot in our projects and where most of our experiences that we are talking about today are coming from. And this is the library C# Functional Extensions by Vladimir Korikov. And as you see on from the download numbers, is pretty well received. So currently, it was yesterday almost 14 million downloads. So that's really very well, really heavily used library. Okay, so let's take a look at how it works. So it also provides us with this idea of the result object. And in the idea, in the action that we had before, where we want to get back a customer, we can just use it basically the same as David already has showed us. So we say, okay, we get from our find method now a result of customer. We can use an is failure. We can access the error, or in the success case, we can access the value of it. So that's basically as we already have seen it. But we can then use fluent extension methods to chain together the operations. And in that case, we could use a tap error method that is used when we are on the failure track, then we want to log something. And afterwards, we can then decide if we are on the success or on the failure track and either return an OK or a problem. What we had before was also the question, besides the question, does it technically work? Did it technically work to talk to the database, or do we also find one of the names that we have to look up? We can even combine those two. So we have here a result of maybe of customer. So that first one, the outer shell, the result takes care of the technical part. So did it in principle work to talk to the database or to our backend system? And then within, if it's fine, we have a maybe of customer, because still it could be that the name that we were looking after was not to be found in the database. And so we have a pretty nice separation of those two concerns. And in this classical implementation, we could first check, is the result itself on a failure track? If it is, then we log the error and return with a problem. Otherwise, we know, okay, we have a value. It is a maybe customer. And then we can ask about the domain side of things. And we can ask, did we actually get a customer or not? And if we did not get a customer, then we say, okay, sorry, we could not find this customer, and we return no content. And otherwise, we just know that in the value of the maybe customer, we have the actual value, we have the actual customer, and we can return it with an okay. Another idea would now be to get back to these fluent extension methods and use them. And here you see the same behavior, besides one logging that we were stitching here, but basically the same behavior from the outside of the user of this action. And we see way less code. So we see a tap error that is used to log the error message, and afterwards we are still on the outer technical side of the result. We match and say, okay, if we're on the success track, we know we have a maybe customer, and this maybe customer also has these two possibilities, and we match now on the, is it a customer or is it not a customer? And here we decide to return an okay or no content. And otherwise, if we don't have a maybe customer, then it was obviously a technical problem, and we would return that from the HTTP method here. We can even stick it a little bit more together. So the change here from the previous version and this version, if I go back and now forward again, it's basically that we have that we have used an even terser syntax, because we now do not have the explicit lambdas here for the OK and for the no content, but we just use the method group syntax. And so it can be even more clear to say in this in the match, we say, okay, and we match on, and on this one side, on the success side, we return okay, and on the failure side, we return no content. So basically no fuzz around. Besides that, the necessity here of this specific API to also mention the type parameters, but that is another thing. And if you consider it better or not, I think that's a lot depends on what we are used to. How do we usually write code? How are we used to think about in such fluent APIs, for example? So that's of course to be discussed. But if you're used to it, it can be really very, very short and crisp. Okay, so let's take a look at the methods that and extension methods that C# functional extensions offer to us. So one important is the map function. And the map function just says, okay, if I'm on the failure track already, I remain there. But if I'm on the success track, then I want to have something else on the success track. And the typical example that you see here on the bottom is you get some customer domain object from your service and you have to map it to a DTO. So just another representation, but it doesn't change the track. You can do the same on the error side. So if you want to enrich the error, for example, with additional info, then we can also use it to change what we have on the error track. Or the match function that we already have seen in several cases where we say, okay, on the success track this, on the failure track this, but at the end they come out with the same type and we can process what comes out of the match method in a single stream afterwards. Okay, if we have a kind of the need to change what we have on the success track, but it could be that the operation that we want to apply on the success track data can also fail, then we can use a bind method. And as we see here in the picture, the bind method now gives us the possibility to, even if we get into it on the success track, to come out on the failure track. And this is usually done if you have a thing where you, for example, have to send to a backend service and those calls can fail, of course, then we have to consider this by using the bind method to be able to come out on the failure track. Kind of similar is the ensure method. The ensure method is most of the time very handy if we have to perform some validation where we have a Boolean or a predicate. So it can even depend on what comes on the success track. And then we have to decide, do we stay on the success track without changing anything, or do we pass over to the to the failure track? Okay. If we are already on the failure track and we somehow know how to deal with this and we can do something about it to get back on the success track, then we can use on failure compensate. That can be handy if you have kind of a fallback in case of failure. You want to return something else. An example here would be to return maybe none if we had some kind of error. Okay. Two things that are really nice, especially when it comes to logging, is if I want to have just my finger in the stream of the success track and just do not want to manipulate it in any way, but just get a hand on what is flowing here, then we can use the tab method, and it is most of the times needed or used to write log messages, for example. You can have the same on the failure track. That's called tab error. And so if you want to log an error, then you can use that as well. Or both tab methods could be used to apply some out of band, so to say, side effects to, for example, class level counters or something like this. Okay, let's take a look at some more or less realistic example. Consider we have a home automation system where you have a super fancy UI on the one side, and you have a lot of facilities within your house that you can control from this user interface. And of course, you also might want to leave the house in the morning and make sure that the dishwasher is finished when you come back and the lights are all switched on. So you might want to consider having an idea of a schedule, for example. And this schedule could be created and maybe then checked for reasonability, for example. Then because heating costs a lot of money, we maybe want to optimize for the heating process. Afterwards, we want to log what comes out of this whole operation. Then we send it to the devices around in our house. And if that works fine, then we just want to update some success metrics because we achieved something, maybe we saved some money over this. And if it did not work out, then we want to also log this error situation. And now we can really go to all of those building blocks and think about what are they really doing and what can be the different situations and modes of operations that they have. So for the first one, for the create schedule, we could consider it could fail because maybe there are some parameters that do not make any sense. So this create schedule on its own could fail. Then we have the validity check, and this is a classical validation, so where we say it's fine or it's not. So it's a yes/no decision. Then we want to optimize for heating, and maybe the initial schedule was so completely destroyed that it's not even possible to optimize for heating. So this can fail as well. Then we have to log, and then we have to communicate to our devices, and of course this can fail as well. And afterwards the logging and the updating. And if we now want to think about how could we implement this by using C# functional extensions, we have to again take at all these possibilities and think about what would they return on the one side and what would be a proper method here. So if a method can fail, then we expect it in the world of railway-oriented programming to return a result. If we have to make a yes/no decision, and maybe if it's a no, go on the error track, then we can use ensure. If we then call something to again modify what we have on the success track, but that can fail as well, we have to use the bind method. Afterwards, we log what is on the success track. There is the tab for it. Then we send it to the device. That can fail as well. So another thing that returns a result. So we have to use another bind here. And at the end, then a tab for the success and a tab error for the error case. If we now take our nice images, we can overlay this whole process and it would look like this. So here you can really see, okay, the success track goes through. We have 3 binds where we somehow manipulate the stuff. And there are several occasions where we could leave the success track and go over to the error case and to the error track and do something with either information, depending on where we are. Yeah, in code, that looks like this, that can look like this. So it's kind of 10 lines of code and a lot is going on there because each line basically represents one of those building blocks we have here. So there's a lot of conditions to be considered and a lot of things that can work or can go wrong, but still it's just one line and just a few statements, a few words within this line to consider. So it's kind of a nice story that we can read here if we are used to this kind of programming. So we see here on the top, we start creating the schedule with a schedule creator, then we ensure the validity, then we optimize for the heating controls, then we are in the way where we want to log something, then we bind it to the result of the actual sending. And afterwards, we still say, okay, if it's fine, then we update some simple metric. And if it's not fine, then we want to log it. Okay, so you see, we are now more in the direction of the reality. And David will now tell us something about our experiences.
Yeah, let's wrap it up a little with our insights, our feelings about this whole railway-oriented programming. So is it a success story now? And I think I can speak for both of us that it's a little bit of a love and hate relationship with it. So we definitely feel the benefits of it, but there are also some downsides we experienced. And one downside is that offering such a chain can be a pain. It can be really, really overwhelming. You change one little thing, one return type, whatever, and the whole chain is one big red squiggle. And the feedback you get from your IDE is like, yeah, this huge type is not matching this other huge type, and you can go find and search what exactly is the problem now. This can be really overwhelming, especially if you start with it, but also after having some experience with it. Another problem we experience is the documentation, in our case with that specific library. But so if we forgot what Bindex actually is, we want to look it up, and it's kind of hard to find it. But to be fully honest here, it's an open source library, so we could, if it's bothering us, we could go there and maintain it and provide that documentation for everyone using that library, just to be fair on this side. Another thing we tend to discuss sometimes is where to actually log. So do you want to log where the error happens? Do you want to have this log distributed into all the functions? The benefit here obviously is that you have all the information about what happened wrong, what the error is. But another one could argue you want to have it at one central position, and that the downside of that would be to lose some details, some information. But you have it on one side, you don't bloat up all your functions with some logging. And here we also just recently considered introducing a custom error type, because our method just returned either okay or 500 problem, but we did not know any details about that. So we went there, introduced a custom error type, and this, in that case, really helped us figuring out, giving us more insights about our application.
Okay, so talking about the reality, in reality, we will not have just code base that is fully built upon result pattern and railway-oriented programming and fluent syntax. But usually we have to deal with both worlds. So the classical world where we have this OOP pattern and have to deal with exceptions, for example, and some parts where we try to be really using this railway-oriented approach and have some nicer code here. What you might tend to come up with at the end is that you have parts in the code that combine those two, if you want to put it positively, but I would actually say it's really at least a code smell, if not an anti-pattern, if you have code like this, where you get from some backend API, you get a result, but you feel the urge to wrap it in a try-catch block because you obviously experienced there could be something happening outside of the railway-oriented approach. And if we have that, I think that's really bad because we have then to deal with both worlds, with the exception world and with the failure track world, so to say. And we cannot really rely on the benefits just of the railway-oriented approach. So we would definitely try to avoid this. And one principal idea and pattern that we can try to follow here is the idea of the imperative shell and the functional core. And the idea is to move all this nastiness that you have to care for if you're dealing with the real world. So in all the communication that goes on from your application to the outer world or to some resources, be it hard drives or some web calls or whatever, to move it out and have there, of course, proper exception handling and do everything that is needed just to satisfy the communication means and to also do logging here. But then just change everything that happens out there and transform it into results and have then a core, and this core should be pretty big, ideally, to have a core where we are in the kind of all unicorns and warm ice cream world where everything is nice and you are just passing around results and no exception will occur. Of course, it's really hard to achieve this, but the idea is basically a good one to follow, and it helps a lot in separating those concerns. Who and where do we deal with the real world, and where can we really take advantage of this functional idea of the railway-oriented approach? Okay, so what are our takeaways from all of this? We have learned that working and thinking in this railway-oriented programming really helps us to keep the design in a way that we have the failure always in mind. So the failure and handling of error situations is not an afterthought that if you stumble across it, then you take care of it. No, because every time you have a result and to want to access what's wrapped inside the result, you kind of always have to also think about what does it mean if we are on the failure track. So it gets, by doing this also, as in a way where we have usually less code and code that is more expressive, and it can be a good story that is read. So of course it might not be a good idea to use your whole process and put it in a 50 lines functional chain. That will be not the best story, I guess. But for very focused parts, it could be really beneficial, and it can be really a nice story to read if you have it there. We also saw that it's kind of nice to have it ready and working, but it can be really challenging to get there because a lot of magic is going on, and you have to understand if something has the red squirrels, how to deal with it, and what is the problem. It definitely encourages you and even forces you to think about your way of dealing with erroneous situation and with exceptions. And this idea that we presented at the end is to have it really very explicit and move it away from the business logic part. And ideally, it's really a good idea to not use it just within one method to have kind of a different syntax, but to really think about in the whole flow of one use case that goes through your system, and you really decide on that flow to use this functional approach. That could be really a good way to get into it, a good way to maybe even transition from an existing code base to a more modern code base, if you will, or to introduce a new feature in that way. And you can just attach it to everything that you already have. So it's no need to really change everything. You can just gradually move there. Okay, some resources. Yes, as we already have talked about, everything by Scott Vlashin is really a very good idea. So his website, F# for Fun and Profit, talks a lot about F#. That's right, but he has a very good talk about the idea of railway-oriented programming. And of course, the idea does not depend on any language. And as we saw, we also can use it in C# here as well. And if you want to dive deeper, we can totally recommend reading his book, Domain Modeling Made Functional, where he talks about writing very expressive and powerful domain models by using those ideas that functional programming give us. So a highly recommendation, even if you're not into F#, but just on the C# side, it's really a thing where you can change your mind about thinking how to implement and deal with complex domain models. Okay. Now we're kind of the end of our talk, and before we come to your questions, we have to give you a heads up to the next edition. It's actually the third edition already of the Code Crafts, of our Vienna-based and Square-hosted conference. It will be again an amazing conference this year, as it has been the last 2 years. There are great speakers already. New speakers and additional speakers are to be announced and come, so stay tuned. Take a look at our Code Crafts website, code-crafts.com, and save your tickets now. Prices are still pretty low, so take the opportunity to get your tickets now, and we will totally looking for seeing you there again. So currently until the next week, so still a week to go for the early bird, and afterwards until 26th of April, so just 3 weeks before the event, it's a slightly higher price. So take the opportunity to get your best ticket now. And yes, if you want to know more about what we are doing, you can follow us on YouTube, LinkedIn, or recently also on Instagram. That's pretty cool and amazing, I think. And yes, I guess now we're ready for your questions. If you have already some questions, please use the live stream on YouTube. We are happy to answer them. Okay, so do we have a question?
We'll take a look at the chat, but right now I only see greetings from people.
Okay.
Greetings back from our side.
Greetings back from our side. Totally appreciate it that you are here. Okay. Yes, then I would say if there are no questions coming up, still a last look. Okay. Yes, thank you very much for your time and attention. If you...
There
is one question.
Hey, I was curious if there are any JSON libraries that implement native error handling. From Georgosto.
Okay, I'm kind of surprised by the context. Okay, so maybe you can give us more context in what sense JSON comes in here. So maybe if you think about, or maybe I could interpret it like this, that JSON serialization and especially deserialization can of course lead to situations where you cannot deserialize a stream. And if there are some libraries out there that maybe already return a result instead of throwing an exception or returning a null if it's not possible. If that's the question, I don't know.
Next question.
But maybe what you always can do if you have some situation where you have to use an API and you don't like how the API is going and you would rather have a result object and could be on the railway-oriented programming track, then you can every time write a tiny wrapper just around it. So for example, in the case of JSON deserialization, if your JSON library gives you a null back in the case it cannot deserialize a stream, then yeah, just wrap that, make a small if, return a result failure in that case with additional information. If it is throwing an exception, make a try catch around it and return a result failure instead. So I think it's pretty easy to kind of get a better handle on the APIs that you have to use but you don't like so much. And that's kind of the basic idea of this functional core and imperative shell, to really move that thing and the nastiness on the outer side of the system.
Right. Yeah. Another question that came up is, did you use an open source project to do railway-oriented programming? So I personally did not.
Yeah, so me neither. So we are heavily using it in a customer project now for years, but it's of course not open source. Yeah.
Exactly. Yeah.
Okay, Giorgio is fine with our answer. Cool, nice, like it. Okay, David, I think it was a pleasure again.
Yes.
And we hope to see you next time again, and stay tuned and yeah, stay functional.
Bye-bye.
See ya.